Welcome to our channel. In today's video, we're diving into the fascinating world of cryptography, focusing on the Hill Cipher encryption technique. This tutorial will guide you through the principles of the Hill Cipher, how to implement it in Java, and how to encrypt and decrypt messages securely. First, let's start with a little background on what the Hill Cipher is. Developed by Lester S. Hill in 1929, the Hill Cipher is a polygraphic substitution cipher based on linear algebra, specifically matrix multiplication. It encrypts groups of letters, using a square matrix as the key. This method makes it significantly stronger than simple substitution ciphers. The Hill Cipher works with blocks of plaintext divided into vectors. For instance, if we choose a 2 by 2 matrix key, we can take pairs of letters as inputs. Each letter can be converted to an integer, where A equals 0, B equals 1, C equals 2, and so forth up to Z equals 25. This will allow us to perform arithmetic with these values easily. To begin our encryption journey, let's set up a simple Java project. Make sure you have Java installed on your machine and create a new Maven project. Open your favorite IDE, such as IntelliJ IDEA or Eclipse, and set it up accordingly. Next, let's create a new Java class named Hill Cipher. This will be the main class where we will implement the encryption and decryption methods. We need a method to generate an encryption key. For simplicity, we will hardcode a 2 by 2 key matrix. We can also allow the user to input the key matrix through some method. Here's how to define the key matrix. To encrypt a message, we will define a method called encrypt. This method will take a string message as input. First, we need to ensure that the message length is compatible with our key matrix by padding if necessary. Let's remove any spaces and convert the message to uppercase to simplify our input. We'll then calculate how many characters we need to pad if the message length isn't even. Now, we will create an array to hold the padded message. If the message length is odd, we will add a dummy character. Let's use X as our padding character. Next, we'll convert the characters into numerical values that we will then encrypt using matrix multiplication. Let's build a loop to process our padded message pairwise. In this loop, we'll create a vector from the 2 characters and multiply it by our key matrix to get the encrypted letters. Finally, we will convert the encrypted numerical values back to letters and append them to our result string. Here's how we can achieve that. After finishing the loop, we can return the final encrypted message. Before we proceed with the implementation, let's look at the complete encrypt method now. Now that we've implemented the encryption method, let's test it. You should create a main method and call this method with a sample message to see it in action. Let's run our code. You should see the output indicating the encrypted message. If everything went according to plan, you're now successfully encrypting messages using the Hill Cipher. Next, let's implement the decryption method. Since the Hill Cipher is symmetric, the same key can be used for decryption. However, to decrypt the message, we will need to find the inverse of the key matrix. Before we can decrypt, we need to calculate the determinant of our key matrix and find its modular inverse. The determinant is crucial because it needs to be coprime with 26 for the key matrix to be invertible in modulo 26 arithmetic. We will create a helper method called findModInverse that implements the extended Euclidean algorithm to find the modular inverse. Using the modular inverse, we can create the inverse key matrix necessary for decryption. The inverse is calculated using the formula INV key matrix IJ equals mod inverse asterisk adjoint matrix IAJ %26. Let's set this up. Next, we will recreate our loop for processing the characters from the encrypted message in pairs. The logic here is similar to what we did with the encryption. In this loop, we create a vector from the encrypted characters and multiply it by the inverse key matrix. This will yield our original characters. Converting the decrypted numerical values back into letters is the last step in this process. Here's how we can do that. To complete our decryption method, we will return the final decrypted string after the loop. Now that we have both the encrypt and decrypt methods, let's test our Hill Cipher class. We'll modify the main method to first encrypt a message and then decrypt it, displaying both results. When you run the code for the last time, ensure that the decrypted message matches the original message. This indicates that our implementation is working correctly. And there you have it. You've successfully implemented the Hill cipher in Java, learning both the encryption and decryption process. Cryptography is an essential skill in today's data-driven world, and mastering techniques like this can really give you an edge. If you found this tutorial useful, please hit the like button, subscribe to our channel for more exciting content on programming and cryptography, and leave a comment below with any questions or topics you'd like to see next.